Hello. In this session, we'll be looking at making an orthographic projection drawing from scratch. Let's go. Orthographic projection is the act of taking a 3D object and looking at it from multiple perspectives to get a 2D representation of the same. So if this is that object, you can look at it from what we call a front view direction, a top view direction, and a left-hand side view direction. But of course, you can look at it from the other three remaining principal directions as well. You can look at it from the bottom. You can look at it from a right perspective. You can look at it from the back as well. But usually we restrict ourselves to a front and a top view and one other view, usually a left or a right hand side view. Now, the reason we do that is because these three views combined give us all the information we want about that object when we want to visualize it in 3 dimensions. So that way we don't have to construct all 6 views. There are exceptions, of course, but more often than not, these 3 views are sufficient. In most UG courses, the engineering graphics course gives you a problem for orthographic projection in the form of this kind of a diagram, which is essentially an isometric view. We'll see what that is later on. So here they'll give you the object itself. They'll give you an arrow that represents the front view direction. And then they'll give you the dimensional information. And then they might give you additional information like cutting planes and so on and so forth. And they'll tell you which views are expected. So here, for example, they want us to draw something called a sectional front view, a top view, and a side view. We'll see what sectional views are later on. But first, let's just try to construct an orthographic view uh, of this diagram. And to be specific, we'll draw these 3 views, a front view, a top view, and a side. Now, I can't cover what orthographic projection is in this session because it's essentially just the act of visualization. And that comes to you mostly by looking at objects from multiple views. Uh, just holding physical objects in front of you or looking at 3D models the way I have here. So that's not really the objective of this session, but we can cover it later on if required. So all I'll be focusing on today is how to convert this kind of a problem for these UG courses to a solution that looks like this. Okay, let's figure out why we are drawing the LHSV, the left-hand side view here in the solution. So the front and top views are always around. And then you're supposed to draw a side view. Usually they tell you which view is supposed to be drawn, but in this case they haven't done that. So I have drawn the view, or rather the side, that is completely visible to me, which in this case is the left-hand side. On the other hand, if you look at some other problems, this one for example, here there's a front view along the x direction, and there's a top view as well. But in this case, the right-hand face is revealed to me. The left-hand side is not. So I'll be drawing a sectional RHSV if that's what they ask me to do. All right. Once again, you can see my mouse clicks and other keystrokes in the lower right-hand corner. All right. Also, I'll be using the template that we prepared last time. So in case you don't have one, you can refer the previous video to look at how to set it up, in which all of our line properties are loaded, our line types are loaded, our layers are set, our dimension properties are set as well, and so on and so forth. All I've done is I've reduced the size of this canvas a little bit, and because of that, these toolbar elements have resized themselves, but they're essentially the same tools. If for some reason you're not seeing the tools I'm seeing here, and the panels specifically, such as draw, modify, etc., you can just switch your workspace to drafting and annotation or 2D drafting, as the case may be in your version of AutoCAD. The next thing we'll do is we'll save this file, because remember from the last session, when you don't save your file, you end up potentially losing out on any live backups. that may get made. All right. So since everything in this file is set up, all I have to do is start drawing. So let's start. But before we do, we need to do two things. First, we need to figure out a general sense of what this object looks like, if all the dimensions are given and so on and so forth. And then we need to figure out where to start from. So let's look at the object. Here, the object is comprised of what I think are two cylinders with holes in them. They've given us these values which represent the diameters of these cylinders. We know that these are diameters because the prefix here is phi. So phi 20 means that there's a circle of diameter 20 here. And this is 30. This is 30, this is 40. Further, we know the center to center distance between them. That's given as 70 units. Then there's this object. It's called a rib, RIB. We'll come back to that when we do sectional views. Its thickness is 8 millimeters. At the bottom here, there's this base plate of thickness 10 millimeters, and then they give us the vertical heights of these cylinders. So all the information that we need about these objects is given to us. So we're not going to have to approximate anything, it's all given. Next, we need to figure out which view to start because there are three views that are expected for this problem: a front view, a top view, and a left-hand side view. So technically, you could start from any one of them. It doesn't really matter because you're working on AutoCAD. You can always do a lot of manipulation as you go along so that you, if you start with one view and you get stuck, you can just do parts of the other and so on and so forth. In this case, though, I'm going to start with the top view, mostly because that's where the majority of the circles are. It's just a preference. You don't have to do it that way. That's what I'll be starting. Okay. Now, again, there are multiple ways of starting in AutoCAD. Like, you don't have to stick to any rigorous sequence, but I tend to, for objects where there is very obvious symmetry, start with a line of symmetry. Okay, so for this object, I'll be starting with the line of symmetry, which is represented by this line running through the center. It's a big dash, small dash line is the center line type. It also represents one more thing. It represents the cutting plane as indicated by these arrows and letters on both ends. But we'll worry about that later. So I'll start with a line of 70 units length and I'll use that to build my top view. Okay, let's start. So I'll switch to my object layer. Even though I know that that line is a center line, I'll change this line type later. And I'll make a small line of 70 units length for which I'll keep ortho on, dynamic input on. I'll keep both of these snapping options on as well. All of these settings should already be existing in the template that you saved last time. So I'll click for the first point. I'll just move my mouse in this direction and I'll enter the distance, that's 70. It looks like a very small line because we are zoomed out a little bit too much, so let's zoom in. You'll notice that I didn't really worry about where I'm making this line in the workspace because it doesn't really matter. We can always move things around. All right. So the endpoints of this line end up becoming the centers of these circles. So I'll quickly make all of those. I'll start the circle command. I'll click this endpoint for the center and then I'll enter the radius value. So for a dia 20 circle, the radius is 10. For a dia 30 circle, the radius is 15. As this is a similar circle over here, I can just copy this if I want, or you could just make that circle fresh. I make the circle outside. Its radius is 20. All right. Then I'll make these edges for the rib. They are 8 millimeters thickness, which means that on either side of the center line, there are 4 and 4 above and below. So I can select this. I'll say copy. I'll select, let's say, the midpoint of this line as my base point. I'll move my mouse up. I'll enter a distance of 4 and then move it down, enter a distance of 4. You could also use the offset command to get the same lines. Then I'll do Control A and TR and I'll just remove these extra portions that are not really going to feature in my drawing. I'm deleting these extra portions as well. All right. The next thing I'm going to do is I'm going to extend this line all the way to the end. All right. Then we have to make the edges of this base plate on both the sides. There are multiple ways of doing it. I'll show you what I think is the fastest. You'll do it with the line command. So start that. And then instead of clicking for a point, you can type tangent and enter. And then click on the first curve somewhere. Then tangent, enter. And then click on the second. The line auto adjusts so that it's tangential to both of these curves. One more time, line command, tangent, click for the first point, then tangent, click for the second. And that takes care of this top view. We've represented this hollow cylinder, which from the top will look like two concentric circles. The same goes for this hollow cylinder. The rectangular plane that represents this inclined plane in the top view, and then these edges representing the base plane. If we compare that with what the object looks like in 3D, it's pretty close, right? What we can't represent in an orthographic drawing is we can't represent the differentiation between solid objects and hollow spaces. So here, this concentric circle and this little circle inside, you can't differentiate between in terms of what is solid, what is hollow. There are ways of doing that, but we don't really concern ourselves with that in orthographic projection. And of course, information about this will become clearer once we construct the other two views. Okay, so what I've done here is I have shifted this line from its object layer to the center layer so that it has the center line type. I've also extended this line beyond the ends of this object because that's a convention you have to follow in orthographic projection. And I've made a line here which represents the top edge of the object's top view. All I did for that was copy the line from the center all the way to the top. Okay, but there are certain orthographic conventions you have to follow, such as keeping a minimum distance between your views and what we call the XXYY separation lines. So those are these lines, these white ones. And in the case of our solution, we are keeping a distance of 20 units there. So what I'll do is I'll copy this up by 20. And then I'll make another copy up here at 40. So for which all I'm doing is moving my mouse up and entering a distance as we did before. Now this line ends up becoming the bottom edge of your front. And this line is the XX line. So I'll just extend it a little bit. And then I can delete this because I don't need it. Alright, next we'll work on the front view. But again, you can do that in multiple ways. The way I'll prefer doing it is I'll extend these yellow lines from the top to the front view. These lines are called projections or projectors, and they just connect different parts of your drawing together. All the views are connected by these projectors. So there's projectors between the front and top, the front and side view, and then there are projectors between the top and the side as well. We'll see how to get these in a quick fashion. All right. So I'll switch over to my projections layer for this. And most of my projections are going to be from the center line itself. So what I'll do is I'll make one of these and then I can make copies. I'm saving a little bit of effort by doing that. Just make sure you end up snapping it where you're supposed to. All right. So that takes care of everything I need to project from the center line, but that's not the end of it. There are a few other things you need to project, and those are not very obvious unless you've gone through a body of work in orthographic projections. So for example, I'm going to project this edge, the edge where, or on the other side, the edge where this plane of the rib meets this curved plane, this edge. I'm going to project that point up as well. And it's going to be very close to this other projector, so I'll have to be careful projecting this. I'll have to do the same thing on the other side as well, so let's do that. Goes from here all the way to the top. And we will be needing these projectors. We'll see how they are important. Similarly, I'm going to project the points where these lines end on either circle. So I'll project this point, and I'll project the one on the other end as well. But these are very minute projections, but they end up making a difference in your final drawing. Okay, that takes care of all the projectors we need to mark. So then we can just start working on the front view. For me, the front view is comprised of three things. There's the rectangle formed by this curved surface, the rectangle formed by this curved surface, and then the inclined rib, that's RIB. So let's quickly make all that. I'll switch back to my objects layer. I'll use the line tool and I'll trace the outline of the whole thing. So I can start from this end and the height is 30. And then this horizontal length should be 30 mm. That's the diameter of the outer circle here. Okay. Then I can go down by 20 units. I can just stretch this line out. I'll start on the other side after that. So this height is 40. This should be 40. Then I'll stretch a line on down here. And then I can trim off these portions that I do. All right. Then I'll make this inclined line that represents the rib slope. And it appears as if we are done. But there are these tiny things that make a difference between people who are good at visualization and the people who miss out on the fine stuff. So here, for example, as I said before, this edge is what ends up being visible. That's the edge that represents the curved surface meeting this vertical plane. Along the same lines, there's an edge formed on the other side as well. But that's not really what we have marked in this view right now. We've marked the length of 30 mm here and 40 mm here. What we need to make this edge at is the projection for this end, right? That's the reason why I projected it. So what I can do now is I'll just stretch it out all the way to the top, and I'll tell you why in a moment. I do the same thing here as well. I need to project this inner point. I just stretch it out all the way to the top, and then what I can do is I can take these two lines. I'm just making a green line around them, and then I'll take this corner and snap. I do the same thing for these three at the top here. I just make sure they're selected, and then I'll take this little blue grip and snap it here. I'll remember then to just reduce the length of this projector all the way down because you don't want these lines overlapping. And then I'll do the same thing on this corner as well. Once again, I'll select the whole thing and then all right. So then I'll reduce this. All right. Now again, it looks like we are done, but we are not. So this base plate at the bottom, it stretches out into the curved surface until it becomes a part of it. Right? So if I look at what's happening here, this edge extends into the cylinder. So we'll have to do the same thing. And how far it extends depends on this projector here and this projector here. So let's stretch it out all the way to those ends, for which I'll just extend this out a little bit by, let's say, 10 units. And I'll do the same here as well. It should be this projector, 10 units. And then I can just stretch this end out all the way to go inside there. And the same thing on the other end as well. we are still not done. The next thing we need to look at is how to represent these kind of edges, which end in curves. So for that, you're supposed to make a small arc turned upwards on both ends, for which I can use the 3-point arc method. I can turn ortho off for a moment and use this as the starting point, and then I'll click somewhere above this line, and then I'll click for a third. I can then mirror this around. Any vertical line doesn't really matter. You just want the opposite, that's all. And then I can move this. So move with this space point. Okay, now that takes care of all the things that we can see when we look at this object from a front perspective. What we don't have in this view, however, are representations for these circles inside, because we can't really see them. They are hidden by this material in front. So whenever you come across these kind of features in these problems where you know that there's a feature in the object, it's just that you can't see it because of material obstructing your view. Those features are supposed to be represented by what are called hidden lines. Their line type is dashed, and we already have a layer for those kind of lines with us. Yeah, it's the dashed line. So I can switch over to that. I can make all the features that are hidden. So in this front view, the only features that will be visible as hidden features are the edges of the holes inside the cylinder. So I'll quickly make those. Okay. The last thing that I'll do for this view is make the vertical center lines that represent the axis of the cylinders, for which I'll switch over to my center layer and I just make these lines. I'll make sure that they are cutting the entire solid as in the cylinder, and that's my front view. Okay, next we'll start working on the side view of this object, before which I'll make a copy of this edge to the right by the same distance as between the front and top and the XX lines. So that's 20 units for the vertical YY separator, and then 20 units beyond that for the leftmost edge of the left hand side. You'll notice that I'm constructing the left hand view on the right of this front view because that's what our orthographic conventions are for the first angle method of projection. So this becomes the leftmost edge. Now we can construct this view without doing any projections work, but I'll be doing the projection work beforehand anyway, so that I don't have to worry about it later. All right. Now for the front and top side view projections, the method is similar to the front and top. You just make horizontal lines connecting all of your relevant points between the views. In this case, there are just 4. And remember to zoom in so that you don't accidentally end up clicking places you don't want. That takes care of that. Now for the top view, the projection is not straightforward. You need to find a way to transfer all of these distances with respect to this point over onto the horizontal edge. Again, there are multiple ways of doing it. I'll be showing you 3 of them. Use whatever makes sense to you. For all of them though, first I'll be projecting all of these points onto this line called the YY line. So I'll keep my projections layer going. I'm also going to turn off this nearest snap, the one for which the symbol is this, okay? Because that will ensure that the points I'm snapping to on this line are perfectly perpendicular. I'll turn it back on afterwards. I zoom in a little bit. I'll start with this topmost point. Then I'll do this. And here the difference is going to be practically non-existent. But you still have to ensure that you're projecting the right point. Then this. All I'm doing is I'm making lines. Now, if I extend this line all the way here, it should end exactly on the top of this circle because they're the same diameter. Then I can project this point for which the distance between it and the one on top is going to be again almost non-existent, but it's still projected. And I'll project this rim. I'll also project the center. Okay. That takes care of all of my projections. Now, since all of these projections have got a symmetric object, what I can do is I can select all of these. I can just say mirror, and I'll mirror around this center line so that I don't have to project this bottom part again. All right, I'm going to save my file once just in case you haven't done it in a while, you can do that as well. And then we go about projecting from the front to the side. What I will do here is I'll make a small line. I may erase it afterwards if I want to. Its length is 40. That's the bottom edge length. That becomes the edge against which I can trim things after projection. Okay, now there are three ways that I'm showing you. The first one is working with arcs, for which the preferred way would be start, center, and end. So what you do here is you pick the starting point of your curve. Let's say it's this. You pick the center, which in this case is this, and then you pick the ending point of this line. You can do that for all of these, and then you can just make vertical projections from these points that you obtain all the way up. That's one way of doing it. The other way is making these lines from each of these points at 45 degrees to the vertical. So for that, I can start with this line, and I'm going to keep ortho off for a moment here. I'll start my line here, and I need to make my line at 45 degrees to the vertical here. So that's also 45 with the horizontal. So I can enter a weight distance, let's say 100 units. I'm saying at the rate 100. Then I'll use the less than key and enter the angle as 45. And then I can just copy this line from this end to all of these ends. And that's how I get my projections. I can then trim off all of this and then project vertically upwards from all the points that I've obtained. I can turn ortho back on, right? And so on and so forth. And then there's the method that I prefer using, which involves these lines, right? I'm projecting horizontally to a 45-degree line and then vertically upwards. So I tend to prefer that because that used to be the old method of projection of orthographic projections, nothing else. Most courses recommend that you go with the arcs method. You can use whatever you like, whatever your course prescribes. Right? So that's how you project. All right, so to pick up on the side view, all I've done here is I've projected from the top to the side, and I've projected to the specific endpoints I'll be needing these projectors to, just to save a little bit of time on screen. All right. Okay, so I'll start. So the most obvious features for the side view here for me are the rectangles of the cylinder at the back and front. So I'll just make those. I'll switch over to my object layer. I can start here at this end, and the length should be 40. I'll just verify that it's ending on the right point. Okay. And then for the top, the vertical height is again 40. And I'll ensure that it's ending on this projector here so that my work has been, verified. And then I'll this that takes care of this rectangle. I'll make the one inside as well, for which the projectors I use are these ones. This and this. Now, just to keep things consistent, I'll highlight these temporarily to a different color so that I know that these are the ones that I want to refer. And I can start the line command from this. Its height is this, its length is 30, and I'll just verify that it's ending on the right projector here. Okay. Next, I'll tackle the rib in the center. So when you look at this object from this perspective, you'll see some of this rib poking out. So I'll make it using object lines again, for which I have these projectors with me. I'll use those. There's one here, one here. I'll just trim off this extra portion. All right. We're still not done with all the visible portions. We'll deal with those first, then we'll look at the hidden lines. But before I do that, I'm just going to make this center line to just make sure everything is confirming properly. And I'm not even going to make it, in fact. I'll just snap this copy here. So then we'll start worrying about the other things that are visible, specifically this base plate. So for that, I see an edge formed here horizontally and here as well. And it'll be projected between these endpoints that I've figured out. So one over here, and then this inner one, and the same ones on the other side. So what I can do is I can make a line here between this and this, and the difference is practically non-existent, of course, but you have to show it, and then make sure that the projector connects there. And then what I can do is this portion of this cylinder in front should not exist after that, because as you can see, there's no edge formed here or here, right? So after that's done, I can take this, I can mirror it above the center, and I can do the similar thing at the other side as well. So Control A, T, yeah, and then this can. All right. So that takes care of the visible features. Now we'll worry about the hidden stuff. So the most obvious ones to you now should be the hidden lines representing these holes. Now these are going to be consistent distances no matter what angle you look at it from. So what I can do is I can be a little lazy. I can copy these over with that center line over here, and they should match up. Similarly, I can do that for these lines as well. I'll just copy with this center line becoming the center here. You'll notice that there's a little bit of overlap between this edge, that's the hidden edge, and then this edge, which is visible. That happens often. In such cases, you're supposed to give preference to the visible edge. So I'll just trim off the hidden edge from here as well as here. Then there's hidden features that are not very obvious. So for example, this vertical edge is formed all the way from the top of the cylinder to the bottom. So there'll be a portion of it that's hidden from your view because you're looking at it from a side perspective, right? So here, or even this angle for that matter, if I just show you an X-ray view, you can see the edges formed at the back of this rib. So we'll take care of that here, for which I'll extend a hidden line from this point all the way to the bottom, and then here as well. Along the same lines, this curved edge that's formed, some of it is hidden behind the cylinder in front. So after this point, on both sides, you'll be stretching out a dashed line on the hidden layer, and on the other side as well. So up to here. And then once these lines intersect, they don't continue. So we'll trim off these portions. All right, and that takes care of this side view. Now, what's left to do after that is to label everything and do dimensioning. So the labeling just uses the mtext tool, right? I'll demonstrate once. You say mtext, make a small text box. Then you increase the text height. I've kept it around 5 here as a default. And then you can type. So you have just labeled these views, a front view, a top view, an LHS an XX line, a YY line. And then there's dimensioning. So for dimensioning, again, just as we saw in the first session, all you're doing is using the linear dimensioning option on the dimensions layer. If you want to show any horizontal or vertical lengths, and using the radial or diameter options whenever you want to show any radii or diameters. And then usually afterwards, okay, what's left after that is labeling and dimensioning so that you can make your view look like this. Okay, let's go delete content. Okay, what's left after that is the labeling and the dimensioning. So for the labeling, you can do labeling for the views, the XX and YY line. I'll demonstrate for one of them. You can just say mtext and then you make a box. And here I've already set the text height to 5. Then I can type my contents. You'll notice that it's coming out in green because I've switched over to my dimensions layer. You can keep it on your separate layer. So let's call it text. And so on and so forth. For dimensioning, just as we saw last time, if you want to show the distance between any 2 points and the distance is horizontal or vertical, you can use the linear option. So this endpoint, let's say, and this endpoint. If you want to show the diameter or radius, you can use diameter or radius down here, and then you can just click outside. And then often a lot of courses want you to have some kind of a nameplate, so you can just use the mtext tool for that as well, and that makes this a proper orthographic projections drawing. You'll notice that I've spread out my dimensions in all 3 views. I've ensured no view is without dimensions, and I've also covered all the dimensions that were given in the problem so that no dimensions are missing. The idea being that if somebody looks at this orthographic drawing, they should be able to figure out exactly what this object looks like from a visualization perspective, and then if required, make a three-dimensional or isometric model out of this scene. Next, we are going to look at sectional views, and they are just a little bit different in terms of the actual drawing tools you use. 95% of the tools are the same. It's just a couple of additional things you need to know. The basic idea of sectional views is you cut your object with a cutting plane, and you then remove the portion that's closest to you, the observer, the thing that's obstructing your view of the cut plane. So if this is my object and I use the same cutting plane that's given in the problem, so that's a plane that cuts all the way from this end to this end, represented by these arrows, and it cuts along the same plane on which you're projecting the front view. That's your vertical plane. Again, these details are available in a lot of orthographic theory on the net. You can just check that out. So I can just do that here. I can select my cutting plane and then I can cut my object with it. Now, after I do it and I look at what's left in this front view, you can see that essentially these holes are revealed. Further, this entire plane is cut. So if I draw a sectional view based on what I see, this is essentially what I end up seeing. I see a hole here, I see a hole here, and I see these surfaces being cut. These cut surfaces are represented by something called hatching. And in AutoCAD, it's a very easy command to execute. Okay, I'll show you how that works. I'll just turn projections off for a moment, and I'll keep this on the object layer. So the command is hatch. And when you do that, you get this panel on the top. The pattern that we select is ANSI 31 for standard orthographic drawings. There are a lot of other materials available, but we just stick to ANSI 31. And then there's this factor that we may have to play around with. That's the scaling factor. Now, the way you add hatching is you just click inside the regions you want to hatch. You can notice that you can't really see anything. It looks like a big block of solid color, right? That's because there's a scale factor involved and the default value is pretty small. So let's increase it. We keep it around 30 or so. That's good enough. So once you're done, you can say close here. If for some reason you want to modify this, you can click back on it. Again, you get this box and you can play around with this parameter if you want. But 30 looks good enough for me. So let's keep it. One thing you'll note here is that I haven't hatched this portion, even though it does get cut clear through and through. And that's because this portion, as I said earlier, represents what is called a rib, RIB. It's a machining part, that's RIB. Right? It's a machining part which tends to connect one part of your object with the other, and it often has this kind of a sloping surface. So for these ribs, there are these conditions for orthographic projection. The first one is that you don't show any hatching inside them when you cut along their longer plane, or rather, the when you cut along its maximum cross-sectional area, you don't show any hatching inside. There are other rules available. Of course, you can check them out. Right? They're available everywhere. Uh, and as a result, I'm not showing any hatching. Okay. The only additional thing I'm showing for this view are these center lines, which we already had in the normal orthographic projection. And then there are two additional things I'll change with respect to our standard orthographic drawing. I'll label this view as a sectional front view. And then you'll notice I'm saying that it's a sectional front view along AA. Here AA represents the cutting plane as given in the problem. And along the same lines, I've represented that cutting plane in the other two views, in the side and the top, with the same center lines. And I have shown these arrows and letters. Now, there are multiple ways of getting these arrows and letters again. I'll be showing you what I think is the easiest one. The command is called mleader. You start it, and then you click for the arrowhead once. Then you click for the endpoint. You can keep ortho on so that it's a perfectly horizontal line. And then afterwards, you enter the caption, which in this case will be the letter A. You can click outside. Now, once you do, once again, you'll notice that you can't really see what's happening. Can't see arrows, etc. So you'll have to go right clicking and saying properties. Then you'll have to go down to the leader section here. And in the arrowhead size, you can increase it, make it about 5. That's visible enough. And then in the text section, you can go and make the text height the same number. Keep it around 5. Okay. Afterwards, you can make a copy of this down here. You can do the same thing at the bottom as well. And then, as per convention, I'll also be making these edges of the center line outside the object of a darker color. And that makes this a complete orthographic sectional drawing. All that's left here is the dimensions. All right. So in this session, we just had a quick run through making orthographic and sectional orthographic drawings using the tools we learned in the previous session. We didn't really get to cover the theoretical aspects or the basic concepts that help you visualize orthographic and sectional views. We'll do that in a later session at some date, but in the next session, we'll be looking at how to make isometric views using the 2D drafting tools available in AutoCAD. I'll see you there, guys.